This is project 5, video number 3, the one in which we do the documentation and finishing touches. First off, let's get the plot labeled. I got title with lowercase t. Title. We're plotting string tension versus string end position on the meter stick. I think I'll try leaving it like that. Hopefully you can come up with a better title than that, but it is the tension in the string versus how far the point where the end of the string is tied to the meter stick is from the pin. So maybe string end position, string end, I'll call it that, position. Okay, and then X label, lowercase x. Point on meter stick at which string is fastened. And it's really the distance that that point is from the pin, but you can only make the title so long. And if we define a x coordinate system that has x is equal to 0 at the pin and increases in the direction in which the stick extends, this is actually pretty thorough. Y label, string tension. Alright, I was worried so much about I was going to title things and I might have spelled something wrong, so let's see if this thing actually works. And I go plot tension. And here's what comes out. So string tension versus string end position, and it is string tension up this way in newtons versus the point on the meter stick at which the string is fastened in meters. So newtons and meters. Better put the units on there. I know I was so worried about what I was going to title them that I'd forget something. So we'll go, this is in newtons, and this is in meters. And try that again. See how it looks. Point on meter stick at which string is fastened in meters, and string tension in newtons. String tension versus string end position. I think we're good. So let's get to put the description in here. State what the function does. Describe configuration. So here I'm not really doing the function description, but I'm telling you what you got to do. Make sure that you do describe the configuration. Talk about, we got a meter stick, it's pin connected at one end, etc. And then your name. Now this part is supposed to go first because in MATLAB, when you're using MATLAB, it tells you that part. while you're running MATLAB, you get to look in this window down here. If you just select that function, it gives you the description of the function right there. So you want to have a nice concise statement to start, and then more information on it to make it a complete description of it as I require it. But a person doesn't even have to look inside the function in order to see what you wrote there, if you put it in the right spot. So don't put your name first and then function description. Put the function description as the very first thing, and then your name. I'm going to go input variables none. Output variables none. Alright. Attribution. Give me some real information here as to what you actually used. I'm guessing that you're going to do this whole project completely on your own, and then check it over by looking at the videos, and then tell me everything was perfect, or I had to fix this, that, and the other thing. Tell me the little things that you had to fix up, and which video enabled you to figure out what you had to fix up, that kind of thing. Don't just say use the video 1 to verify the pencil and paper part, etc., or to help out with. Just give me some details. Just say what you actually did. So, but whatever you do, don't forget to put down the attribution. Alrighty. Any sections of the code look difficult? Here we're setting up the x variable. The tension depends on x, and then we plot it. So I don't think anything needs additional explanation there. Let's see if these variables make sense. If somebody knows what's going on because you gave them a nice description of it, we got a meter stick, a pin to one end, etc. It's pretty clear that's got to be the mass of the meter stick. People know what G stands for. The length of the meter stick is 1. That even tells them that you're working in meters. And then you told them that the other end of the string is tied off at a height 0.5 meters above the pin, so that should make sense to them as well. And yeah, I don't even think we have to explain what these internal variables are that we've defined to keep things so that it looks like the expression that we developed using the pencil and paper part. So I don't know. From memory, I think I got it, but I'm going to go ahead and use the handout as a checklist. 112 grams equilibrium. Takes no arguments, returns nothing. Oh, how do you like that? Returns nothing. Arc. Produces a graph of the tension of the string versus x. Okay, for 1 centimeter to a meter, that's 0.01 meters. We did that. Units within square brackets, not parentheses. We do have units. Well, the checklist would have helped me out there if I had forgotten that. Okay, include in pencil and evaluation of your algebraic result at x is equal to 0.75 meters. I remember using that, so I must have done that. So at x is equal to 0.75 meters, we get this value, and that came in handy. 4 diagrams. Sketch, original free body diagram, vector component diagram, new free body diagram. Let's check on that. Sketch, original free body diagram, vector component diagram, good. I got arrowheads on my vectors. And those are, maybe I should call it component vector diagram. and the new free body diagram. So with the tension force being replaced by its components. It's an FTX right there, so yeah, that looks good. Alright, complete algebraic solution. Sure enough, I've solved it for FT. I chose to do back substitution. Could have left it like this, and then R would have been something that was calculated inside. I chose not to do that. I was thinking R is going to be an array, and I prefer doing it this way this time. In hindsight, I think it looks a little neater like that, and then all I had to do was calculate R inside the code. That probably would have been slightly better, but it works the way it is. Evaluation of your algebraic solution. Okay, for the test case, got that. Outline of the steps. Got that. Reasonable attempt. I certainly made that. One or more .m files. I saved it as a .m file. Got to do what it's supposed to do. Nothing getting printed to the command window. And yeah, I got nothing there. And there's a reason for that. I got semicolons at all the places where a value was assigned to a variable. Including here. I had that off for test purposes, but I got it back on. Okay. One point for documentation. You must have your name in it. Wouldn't that be terrible? You lose a whole point, a quarter of the project, just for leaving your name out of the .m file. We got my name in the .m file. Your code must be documented for each function. All we have is the one function, not our plot tension. A comment starting on the first line after the function statement, stating what the function does. I left out the word does in my description, but stating what it does. And another set of comments providing a list of arguments of the function, the input variables with beside each argument. Returns no value, statement returns no value. So here we go. Input variables none, output variables none. That's my statement in writing that it's got no return variables. For the case of a function that includes segments that are not self-explanatory, I check that. I find the whole thing to be self-explanatory. You must provide attribution. Make a meaningful statement there. Please don't just say, use the videos. For any case in which a function produces one or more graphs, each graph must be titled. Alright. The graph is titled. Each axis must be titled with what is being plotted along that axis, and in square brackets, the units of what is being plotted. What is being plotted along the x, what on the meters, in meters. You might be able to come up with a better name for that fits in there. The distance from the pin, distance of string end from pin, something like that. String tension along this axis with the units in square brackets. And the tick marks labeled with values, they come up automatically, but there they are. Tick marks, tick, 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 and the values 0 through 1 here, tick, 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 and the values 0 through 60 newtons. So I think that covers the whole checklist. I claim that this project is done. It's got all the finishing touches and documentation. So I'm going to call this a wrap for Project 5, Video 3.